Hello students, welcome to the class. Let me just check if I'm online. Right. Okay. So today is the second class in this measurements, right? We started with the first class yesterday. So we were covering the topics from physical world and measurements. So today is the second class, an introduction to measurements. So my name is Mohana. I'm a physics educator at Unacademy. So I have my master's degree in physics and I hope I can help you with your class 11 preparation. And I've shared my Telegram group link over here. So in this link, whenever I go live, right, before I go live, I would be sharing the link for of my class in this group. So you can actually check out this my group for any updates. So before any classes go live, I would be sharing them in the Telegram, in my Telegram group. And also there is one other than my group over here, right? There is also another common channel, Telegram channel for Unacademy ICSC and ISC boards. So you can actually join the channel over here as well for any updates. And before I go ahead, just give me 1 minute. Okay. Now, alright, so just like how we have these special classes on the YouTube platform, we also have special classes on the Unacademy platform. You can take these special classes are absolutely free. You can take any of your favorite educators classes for free. So one of the interesting features we have at the Unacademy platform is the pool feature. So let's say you're learning any topic. So today's topic, if you're learning measurements, so you can learn about the topic and you can answer some questions about the topic in pool types. All right, and so which way you can actually gauge whether you've understood the concept or not. Okay. And we also have, since these classes are live classes, so you can, whatever doubts you have in the classes, you can immediately clear them then and there. All right, so the next special class for class 11, it is going to be today. Chinmay, right? Hi Chinmay, I hope I'm pronouncing your name right. Good afternoon, Chinmay. And the special classes that is happening in the platform, we have one class today at 4 p.m. right? And in the special classes on the channel, as of now, we are covering the units from your third unit, force. Okay, we have just started covering some topics from there. So in today's class, we are actually looking into a third unit, which is basically dynamics. So we will be covering the topics from introduction to law of motions. And on 30th, again, we have another special class, and that is on again the dynamic topics, the third unit, dynamics. Again, we will be covering the unit from concepts from introduction to impulse. Now to access this course, you can go to the website and go to the special class sessions, right, the free class sessions, and you can use my code MTIS10. Okay, so this will unlock the previous special classes I have done for the unit 1 and unit 2 as well. Okay, now other than the special classes, in case if you're interested in taking a plus subscription, so there are certain advantages over the plus subscription. So since you can learn from the comfort of your home, and you get unlimited access to all courses, and all the educators at the platforms are good, so you will be learning from the top educators. And one interesting features we have is the doubt clearing session. So any course that you're starting, any plus course that you're starting, every fourth session, right? Every fourth session is a doubt clearing session. Okay. So the last 3 classes, whatever you've learned, you will be clearing those doubts those doubts regarding any doubts you have for the topic. You can ask them in this doubt clearing sessions. And in the plus courses, obviously, we'll be covering the entire syllabus. And also, we have a live test series. So this test series is to let you, like, let's say if you're learning any topic, right? If you want to understand that whether you understood the topic well or not, you have to, best way is to take a test, right? So that's why we have the live test series. So after the live test series, there will also be analysis session. So in the analysis session, you can ask your doubts, and if in case you got any questions wrong, you can actually you can ask the educators on how to do that right. At the same time, even if you want to ask of any doubts like how to do this question in a much more easier way, you can ask the same. So there are more upcoming batches, so do check out. I would tell you about the upcoming batches by the end of the class. Now, if you look at the course pricing, as you take the longer duration of courses, the price per month reduces. So if you're taking course for class 11 and 12 together, then obviously for 2 months, for 2 years if you're taking the course, then obviously how much you're paying per month reduces. Okay, so now if you can get any plus subscription in the platform, you can use my code MTIS10, and over here, right, if you take using my code, you would be getting a 10% discount of the same. Whatever course price it is, you'll be getting it for a 10% discount. And next, yesterday's class we started with the need for measurement, right? We started with the topic for need for measurements. If you have any doubts from last class, you can actually ask me in the comment section, right? And here, so basically we started off with learning that physics is a science. Physics is basically a science that explains the nature and the natural phenomenon around us, right? To understand the nature of the natural phenomena, we need to do some measurements, right? And we should be able to measure quantities, and we should be able to compare them. That's where the need for your measurement comes in. Okay, and whatever measurement you're taking, the instrument that you're using should also give you the value for the value that the instrument is giving should also be high. Okay, now your physical quantities, these are nothing but any quantities that you can measure are basically your physical quantities, right? All quantities that can be measured directly or indirectly in terms of which laws of physics can be expressed, those are called as physical quantities. So, for example, if you want to see what is your heart rate, right, per minute, that measurement of your heart rate per minute, that is a physical quantity. Okay, you can measure that particular quantity. But if in case you want to measure how anxious you feel or how happy you feel, right, that is not something you can measure, right? Those are not physical quantities. Okay, physical quantities are measurable quantities which comes within the laws of physics. Alright, now these physical quantities are of two types. One is fundamental quantities, another one is a derived quantities. So fundamental quantities, they exist independent of any other quantities. Alright, now derived quantities are nothing but using the fundamental quantities. If you're deriving, these derived quantities can be obtained. So mass, time, length, all of these are fundamental quantities. But if you want to derive what is the speed, right? If you want to do distance by time, gives you speed, right? Velocity, then those are basically derived quantities. So if you know velocity, then from velocity you can find acceleration, right? So those are basically derived quantities. Now, any measurement that you're doing, any measurement that you're doing for a physical quantity, right? There is a unit associated with it. Okay, so if you want to express any physical quantities, let's say you want to say let's say for example your height is around 5 meters, right, or 5.5 meters, right? So there is a numerical part associated with it, right? This is the numerical part associated, right? This basically talks about height. Height means we are again talking about length, correct? So here so if you're talking about any physical quantities, right, that physical quantity has a associated numerical part, okay, and along with that and a unit with it. Okay, so this is the magnitude, this is the unit. So there is any physical quantity you're giving in terms of a numerical value part as well as a unit part. Okay, now all right, now if the unit goes smaller, right, the numerical part goes bigger, right? So over here, if you want to say 1 meter is basically 100 centimeters. So if your units goes smaller, the numerical part goes high. Okay, this is the second point to be noticed. Now this we quickly recapped what we did. Okay, very basic introduction recap I gave. Now let's go with the system of units. So different parts of the world, right? The way you can actually measure different physical quantities and using different kinds of units. All right. So based on that, there were around 3 or 4 types of system of units. The first system of units we are going to see is basically the CGS system of units. All of the system we are going to see here we will discuss only about the fundamental quantities. Okay, the CGS system, this is nothing but the CGS system basically consists of the CGS system is also called as a Gaussian system. The CGS system we basically call it as a Gaussian system as well. The CGS systems, they basically CGS, they actually stand on. Let me just get. So over here, if you go with CGS, Shashank Roy, CBSE level is same as ISC level. The syllabus, the topics on most part will be same. If you want to compare the topics, Shashank, you can actually look at the official websites. There would be syllabus given over there. So one thing, if you want to look through the entire syllabus, you can just download the particular class 11 syllabus from CBSE, right? Official websites. From ISC official website has the syllabus itself, and from there you can actually compare the content. Mostly the syllabus is same. You might in CBSE, in ICSE, you will have the 1 or 2 topics could be moved. Okay. I hope that answers your question. Right. So CGS basically stands for centimeter. C stands for centimeter. Right. G for gram. S for second. So basically here, if you're measuring length, okay, so length is basically given in terms of, in CGS system, length is taken as centimeters, right? And mass, or your weight you're taking, mass is taken in terms of grams, and time is taken in terms of, you're welcome Sishank, time is taken in terms of second. Okay, so this is your CGS system of units. Now, basically the CGS system of units are again metric system of units. Metric system of units means here we make use of powers of 10. Okay. Now, so any units that you're taking, right, that you can use powers of 10 to express the corresponding fundamental units. All right. So metric system actually means, so metric systems or decimal systems, right, these actually mean this is basically because the multiples or the submultiples of fundamental quantities of fundamental units these are basically obtained in powers of 10. Powers of 10 of the corresponding fundamental units. Okay, so metric system, or in case decimal system, means the multiples or submultiples of fundamental units are obtained in powers of 10s. Okay, of the corresponding fundamental units. Okay, Guys, I'm really sorry, just give me 1 second. Just give me 1 minute, I'm just checking. Okay, all right, guys. I'm really sorry about that. Okay, so again, after the CGS system of units, right? We have the FPS system of units. This is based out of your British system of units, and nobody uses this mostly. Over here, what we are seeing is F stands for foot, right? F basically over here stands for foot. Right, F basic FPS. So your F stands for foot. So length is measured in terms of foot, weight is measured in terms of pound, right, or mass is measured in terms of pound, and time in seconds again. Okay, these are the three fundamental units for length, mass, and time. Okay, the next one is the next one is your MKS system of units. So in the MKS system of units, it basically stands for, right, the MKS system of units. So over here, the MKS system, this is again a metric system of units. So M stands for meter. So any measurement of length is taken in terms of meter, and any measurement of mass is taken in terms of kilogram, right? And any terms in any measurement of time is taken in terms of second. Later on, one more quantity was added, which is basically your current. Okay, so current was fourth quantity that was added was current. Current is measured in terms of amperes. Okay, so this MKA system of unit later when ampere was added also came to be known as MKSA system of units. Alright, and then around 1960s, right, because all of these different system of units is following different measurements, correct, the different units they are following, right? So around 1960s, right, the international system of units, they actually acquired they said, okay, hereafter let's make the SI system of units is the became the international accepted units. Let me just check. COILI, right, is for NEET. Are you asking is this class is for NEET? Shaurya, right? I hope I'm pronouncing your name right. This class is for class 11 ISC boards. Okay, so in case if you want to look for NEET, I'm actually not teaching for NEET on this channel, but you can actually check out the Unacademy app. There would be educators teaching for NEET. All right. Okay, so right, so SI system of unit was accepted in, okay, so according to this SI system of units, right, this was worldwide accepted. Okay, and this SI system of units has 7 fundamental quantities, or we call it as 7 basic units, right, and it also has 2 supplementary units, right, it also has 2 supplementary units. To 7 fundamental quantity and its associated units, and this has 2 supplementary quantities and its associated units. All right. Okay. If you have any questions till what we have done till now, you can ask me. I'll answer your question and then I'll move forward. Okay. All right. So moving forward, what are the SI system of units? Let's first see what are the basic units, right? In the basic unit, all derived quantities can be obtained from your basic quantities. So the basic quantities over here are length. The first basic quantity you're saying is length. In SI system of unit, again, it's also a metric system of unit. It is this SI system of unit, we are following it worldwide, right? Length is given in the unit of meter. Okay, and the symbol we use for it is M. Okay, next mass, next quantity we are seeing is basically mass. Mass, we take it in terms of kilogram. The unit we are using for mass is basically kilogram. Okay, and the unit we use is kg. And time is again the unit used is second, and we use the symbol S. Okay. Next is electric current. Again, electric current is measured. The unit of electric current is ampere, and we use the symbol A. Next comes your thermodynamical temperature. Temperature, the basic unit that we use, the fundamental basic unit we are using is Kelvin, and we actually use this letter K. Next is amount of substance. This is something you will come across more in basically your chemistry. Amount of substance is basically given by mole, and you use the symbol MOL. Right? Luminous intensity, this basically talks about luminous intensity talks about your brightness. This is given by candela, and the unit used is CD. So these are the 7 fundamental quantities in the SI system of units. These are the fundamental quantities, name of the fundamental quantities. These are the name of your units and the symbol that we are using. Now, all derived quantities can be obtained from this fundamental quantities. Now, apart from this, there are also 2 supplementary quantities. One is basically your plane angle. Okay, your plane angle unit is given by radian, and the symbol is RAD, right? And then you have your solid angle. Solid angle is basically given by steradian, and this is basically given as SR. Now, what is a plane angle? Mostly, last class we basically saw what was length, right? We looked into the different units, and also how to convert the from how to express 1 light year in terms of meters. We also expressed how to express even in terms of what is 1 astronomical units, and many quantities regarding length we studied. We also studied about order of magnitudes, right? Right. So now we'll just look into this unit of plane angle. So plane angle that you're seeing is very simple. Let's take a circle. Okay, so from the center of the circle, let's say that it's an arc. See, if this length over here, this length that you're seeing over here, this is an arc length. Okay, this what you're seeing over here is basically our arc length. Okay, and of this circle, this basically gives the radius, right? So this angle theta is basically your plane angle. It gives you the plane angle theta, and the plane angle that you're seeing over here, this angle is equal to, right? In this plane angle, this theta is basically in terms of radians if you want to give. Okay, so angle in this case, the unit is radians. In terms of radians is basically equal to, what is my arc length? Arc length is this portion. If you're looking at a small portion, what is your arc length? Okay, by what is the radius? This gives you the solid angle in terms of the solid angle in terms of your the plane angle, right? This gives you your plane angle in terms of in radian. Okay, so basically, if you see, sun is over here in the center, right? And earth is somewhere over here, and if it's moving this distance, if earth is moving a particular distance, you can actually measure this angle over here. Although we are going in an elliptical orbit, so that distance, if you want to measure, we can make use of this plane angle, right? So plane angle over here, this plane angle in steradian, right? So from here, 1 radian, if you want to describe 1 radian, this is the plane angle. If you want to discuss this unit, 1 radian is the plane angle, okay, between two radii of a circle which cut off on the circumference over here, the circumference, right? This entire length gives you the circumference. So there is a particular length that is getting cut off, right? Cut off on the circumference and arc equal to the length of the radius. Okay, so if you see, from here to here, this gives you the radius of the circle. From here to here, again, this also gives you the radius of the circle. So if you want this plane angle over here, this plane angle is equal to this arc length. This arc length is nothing but for a particular circle, for the circumference of the circle, that is small arc that you're taking, right? So this small arc length, and this arc length is equal to the radius of this circle, right? So 1 radian is the plane angle, of a circle. Okay, 1 radian is a plane angle between two radii of a circle which cuts off on the circumference and arc equal to the length of the radius. So this arc over here is equal to the length of this radius. So if you want this plane angle over here, right, you will have to take the arc length. What is the length over here? By the radius of the circle. Then that gives you in terms of your radian. Okay. Now, from here we can say the plane angle, right? For a circle will have, if I want to take a complete circle, so that circle is basically going to be 360 degrees. One circle has 360 degrees, right? This 360 degree is equal to 2 pi radian. So if 360 degrees is 2 pi radian, if I want the value of 1 radian for a circle, 1 radian is equal to what? 360 degrees divided by 2 pi. What is 360 degrees divided by 2 pi? This would basically be 57.33 degrees. This is around approximate values. Alright, so this is the meaning of your meaning of your plane angle. Solid angle, same way, instead of a circle, right? Right now, if you're taking a sphere, right? And let's say from the middle of a sphere, you sort of just has a cone type of image, right? Just make sure like that is suspended towards the surface, right? See, similar to this thing, so that if you have a cone type of an image suspended towards the surface for a sphere. Okay, now this angle over here gives you the solid angle, which depends on Nitish, good afternoon, which depends on the area over here, area of this part by this length over here. Okay, so if you want to give if you want to express solid angle is basically given as, right, solid angle is given by steradian, and that is the unit of the steradian is the unit of the solid angle, and 1 steradian, again 1 steradian is the solid angle which angle with its vertex at the center of a sphere cuts off an area on the surface of the sphere equal to that of a square having sides of length equal to the radius of the sphere. So when you're talking about, when you're basically talking about, right, steradian, when you're talking about the solid angle, you're talking about a 3D structure. Solid angle is basically for a sphere, and here we can say this 1 steradian is basically what? So if a small surface, let's if you have a sphere, okay, a ball, just take a ball, let's say you're in the center of the ball and you're looking at the surface, right? And if you have a sphere around you, and if you're looking at the surface, at one particular surface of a sphere, right, then there is a, then we can, from the center you're looking at one particular surface on this particular sphere, right? Now this angle is your solid angle. Okay, now this, if the surface, yes, right, cuts off a particular surface, right, this, let's say this particular sphere has a radius r, and of the total surface, let's say this surface over here is yes. Okay, now the solid angle which we give it by phi, the solid angle is given by this surface over here, right, surface by r square. Now the total, right, the total solid angle, right, suspended at the center of the sphere is 4 pi steradian. Okay, so S will be equal to, for a circle, for a sphere, S is equal to 4 pi, that is the total angle suspended at the center of the sphere. Okay, so this will be 4 pi into r square. So this will be 4 pi r square divided by r square. The angle becomes 4 pi in case of a sphere. Okay, now this is about the two angles. Now last class we have seen about length, right? The next unit that we are seeing is basically your mass. So how do we define a mass, right? Mass is nothing but, unit is basically, kilogram is basically the unit of mass. So mass is basically given as 1 kilogram. 1 kilogram is defined as the mass of a platinum iridium cylinder that's kept in Paris. Okay, this basically is the definition for 1 unit of mass. Okay, similarly for the unit of time, we have seen that 1 second, right, 1 second, this 1 second is actually defined as the time interval time interval in which cesium 133 atoms, atom complete, right, 9,192,631,770 vibrations. So that's very accurate. Vibrations in an atomic clock. Why do we need time to be that accurate? Because unless and until all of your basic measurements has a extreme accurate value, the GPS system, which is very much we are using, we are so dependent on your GPS, right? But the global positioning system, that the GPS is so dependent, right? Or this is basically based on the time, right? You have to be able to gauge which in case of GPS systems, if your time that we are saying, right, what you're measuring, it is not very accurate, means if you're not going to a very high degree of accuracy of time, the GPS system will not work this effectively as we are seeing right now. Okay. Similarly, the ampere is of entry over here. The smaller units, if you're seeing for grams, right? So I guess we have already seen the units, but in microscopic physics for seconds, right? If you have one shake, you have a unit called one shake, which is equal to 10 to the power of minus 8 seconds. But we have already seen yesterday for the other units, that is basically 10 to the power of minus 3, this is milliseconds, 10 to the power of minus 6 is microseconds, 10 to the power of minus 9 is nanoseconds. These we have covered in the last unit itself, right? Next, if you're talking about your amperes is also very simple, right? Amperes is nothing but the constant current that is flowing in two infinitely long straight parallel conductors, of wherein the conductors has a negligible cross section when they are placed in vacuum in 1 meter apart. Okay, this basically produces a force of 2 into 10 to the power of minus 7 Newton per meters of their length. Okay, that is basically defined as your amperes. Okay, and then Kelvin, 1 Kelvin is nothing but Kelvin, if you're looking at, this is Kelvin is the SI unit of temperature, and the definition for 1 Kelvin, the definition for 1 Kelvin, right, definition for 1 Kelvin is nothing but it's equal to 1 by 273.16, right, of those thermodynamical temperature of triple point of water. Again, mole of substance is also very simple. It just says mole of substance is basically, it just says how much, right, the amount of substance of a system that contains as many elementary entities as the elementary entities being like atoms, molecules, or ions, electrons, or similar groups of particles are there in an atom of 0.012 kgs of carbon-12. Okay, so that becomes your amount of substance. Now from here again here today, let's look at some of the so before we go ahead, one more important thing to notice is that what are the characteristics a unit should have. The characteristics a unit should have. What are the characteristics of a unit? The units that we are taking into consideration, the unit that we are taking, this unit, they should not vary with place and time. That is your, all the 7 basic units, or the derived, because derived units are again taken from the 7 basic units. The units that you're considering, they shouldn't vary based on your time and place, okay? And it should be, we should be able to reproduce them easily as well. And this unit should be well defined, and they should be imperishable. Okay, and it should be of a proper size as well. It cannot be too large, it cannot be too small as well. Okay, it should be of a proper size. Okay, now these are some of the characteristics of your units. And what are the advantages of your SI system of units? Now the SI system of units that is worldwide used is basically, the advantages is that one is it is logical and coherent. What does logical and coherent mean is that a coherent system means the system is based on certain set of basic units, from which using the certain set of basic units you can get all other derived units are obtained. Either you can multiplying or by division. For example, in the SI system of unit, we have the distance is given in terms of length, right? Distance is given in terms of length, and time is given in terms of seconds, right? So if you know what is distance by time, then you will know your velocity, right? So if you know your velocity is a derived, so now you have defined your velocity, right? Now also, in case if you know what is your velocity, right, from there you can get acceleration, right? Then mass times acceleration gives you force. So SI system of units, the system of units, its advantages is one thing is because it's logical and coherent. Using the 7 basic system just by addition or multiplication, right, you can get the other derived units. Okay, that's the first point. Next one is these units should be easily reproducible as well. Okay, these SI system of units are easily reproducible. They should be easily reproducible. That it is easily reproducible as well. Okay, and this system of units should be invariant with time. Invariant with time means it shouldn't change with time. Okay, so they are invariant in time. They should be invariant in time, and because these units shouldn't change with time. Okay, and and also the SI system of unit is also a rationalized system of units. Okay, SI system of units are rationalized system of units, meaning if you're talking about heat energy, right, or electrical energy or mechanical energy, any forms of energy you can taking, it can be measured in terms of joules. But if you're taking CGS system, they have different units in different cases. But here, even if you take heat energy, electrical energy and mechanical energy, any sort of energies can be given in terms of one basic unit, that is your joules. Okay. Now, this SI system of units should also be a comprehensive system of units. Comprehensive system means this 7 basic units and the 2 supplementary unit covers all branches of your science and technology. Okay, any quantities you want to derive in any of the branches of science and technology, right, you can use the 7 quantities and the 2 supplementary unit. Okay, that's why we say that the SI system are comprehensive as well. Now, the SI system of units, right, it's very easy to it's very easily can be converted into CGS. Right, SI system can be easily converted to CGS system of units as well, because CGS follows centimeter, right, gram second. SI follows meter, kilogram second. Right, so these units can be easily can be reproduced. Then again, it is a metric system of units. The SI system are again metric system of units. Okay, the multiples, all right, or submultiples that we have in any case can be expressed in terms of powers of 10. So you can express centimeters to meters just by using powers of 10. Okay, so that's why we say these are metric system of units. So these are the advantages. Some of the rules, right? Some of the rules for using the units. Whenever you're using a unit, right, in a symbol, for example, let's say force is given by Newton. So if I say 50 Newton, what are the rules for writing these particular names? Okay, first rules that you're following is most of the quantities, fundamental quantities that you're seeing, right, most of the derived quantities also, any quantities if you're seeing in their based unit, the unit might have the name of the scientist who discovered it. Okay, right, in such cases, so force was basically given to Newton, right. Now, whenever you're writing Newton, right, we have a convention. When we write a name, we give capital N, correct? But in this case, whenever you're writing a Newton, we say we write the name in small letters. Okay, Kelvin, again for temperature, Kelvin is again written in small letters if you're writing the full name. But if you're writing just the initial alone, right, if I want to write 50 Newton, just the initial alone, then the initial alone you can use capital. Okay, similarly for Kelvin it will be K, for amperes it will be capital A. So if you want to express current as 1 ampere, so you write ampere in short form if you're writing the full form, but if you're just writing the capital letter, then you just use the capital A. Okay, now symbols doesn't come in plurals. You say as 50 Newton or 300 Kelvin, right, or you say 6 ampere, but it's never amperes, it's not plural. Plural forms are not allowed. Okay, plural forms are not allowed. Okay, so example, even if you're writing kilogram, right, kilograms, this is not allowed. Kg is allowed, kilograms, GS is allowed. Okay, meter is allowed, meters, plural form with the S is not allowed. Okay. Now, whenever you're writing, right, the units, whenever you're using the short forms, right, when we use the short forms, we have a habit of putting a dot, meaning this is an abbreviation or the extension of this particular name, right? But in this case, in place of units, you're not supposed to do that. Okay, so if you're not supposed to put a full stop, you're not supposed to, no full stop, comma has to be put after the symbols. Okay, so if you're writing M, S if you're writing, no full stop. Okay, M if you're writing, those also has no full stop or comma after the symbol. Okay, and most of the time the units are given just with the first name. See, if it's Newton, we give N. If it's Kelvin, we give K. Okay, except very few units like your Hertz. Hertz, we give it in the name of headset. Pascal, we give it as PA. Okay, and candela, this again we give it as CD, and mole we give it as MOL. Except very few units, all are kg, again we'll give it as kilograms, right? Over there K actually means thousands, right? 10 to the power of 3. So except those, these few quantities, right? Except very few quantities, all of the units, or except very few units, all units are given with just one numerical, just one capitalized word. Okay, next, you have to, in case if you're writing a decimal, let's say I want to say the current through a circuit is 0.5 amps. Okay, 0.5 amperes. In that case, before the decimal, you should always put a 0. Okay, now if you're expressing in terms of multiplication, let's say you're saying Newton meter. Okay, Newton meter is allowed. Okay, but this is allowed, right? You can leave a space, or even you can, if you want, you can raise a dot. This is allowed. Between them you can raise a dot, but this, writing it as an hyphen, this is not allowed. Okay, or with a multiplication sign, these are not allowed. Now, in case of division, right, if you want to say Newton per meter, right, then in such cases, so meter per second, velocity if you're saying Newton per second, because it is distance by time, right, meter per second. In that case, you can use the solid line, right? You can either use the solid line, or you can write it as ms inverse 1. This is allowed. Okay, so you can either use this, or you can use this symbol. Or you can write it either the slash, the solid as the sign, or you can write it to the terms of the negative powers. Alright. Next, what we want to see is that compound prefix should be avoided. Meaning, let's say I want to say right, pico, right? See, this is micro is basically 10 to the power of minus 6. Okay, that is basically a micro. Okay, so micro is given by the symbol mu. Right, you can't write mu. 2 micros you can't write, or you cannot write millimeters, right? mm. Right, milli, to indicate that two compounded prefixes cannot be added. Alright, so if you want to say something is the time is actually 10, let's say time is 10 microseconds. Okay, so you can say 10 mu seconds. Okay, or you can say 10 into 10 to the power of minus 6 seconds, right? But if it is, in case it is not micro, but if it's 10 to the power of minus 12, right? 10 to the power of minus 12 is actually pico. But you can't write, okay, you can't write, if you want to explain 10 to the power of minus 10 into, like let's say you want to say 7 into 10 power minus 12. 7 into 10 power minus 12 seconds. If you want to write that, you cannot write microseconds. This form is not allowed. Okay, then hyphen, you cannot put hyphen between the numbers unless and until the hyphen that you're placing if in case you're using it as an adjective. For example, 16 millimeter film. Okay, if you're using it as an adjective, okay, then yes, you can. But if you're saying the thickness of a glass film, right, is 16 millimeters, Okay, that you write it as the thickness of the glass film is actually 16 millimeters. Hyphen cannot be used. Okay, whenever you're writing any units, for example, you're writing 7 kgs, there should be a gap between the unit and the numerical value. Okay, so these are the rules for writing the units of the SIs, the symbols of the SI units, and we have also seen the advantages of the SI units, and we also have seen the 3 system of units, and also we have seen about the SI system of units. We have covered the basic units. What are the basic 7 basic units and the 2 supplementary units as well. Okay. So if you have any doubts, you can ask me in the chat box. Right? Or else let's learn about the different okay. So or else we will learn about the different measurements. We'll start at least with the different ways of measuring length. Okay, distances. Okay, to measurement of distances, you can do it by different methods, right? If you're measuring a very small angle, right? Let's say I want to measure this pen that I have in my hand. So I can use a scale, correct? If I want to measure this value, but to the accuracy of 2 decimal point values, what can I do? Then I can make use of a least count. I can make use of a vernier caliper. If I want still more accurate than that, then I can make use of a vernier caliper, screw gauge. Right. Now this is in case if I want to go down. Right. If you want your answers to be in your decimal place values, so up to 3 decimal place values, if you want, you can do this. Okay. But if you want to measure distances, in case if I'm here and let's say you at a distance you're seeing a tree, and if you want to measure the height of the tree. How could you do that? So to do that, there are different ways in which you can measure. One is the measurement of distance, right? The distance measurement. Okay, measurement. So this is measurement of length. Measurement of length can be done in 2 ways. One is using a direct method, right? Another one is your indirect method. Using indirect method, there are okay, in indirect method, there are many different methods by which you can measure. Okay, the first direct methods that I said. So for measuring smaller objects, we can do this, right? So with this use of a scale, any type of scale, your screw gauge or your vernier calipers or a meter scale, you can measure lengths. That is direct scale measurements. Now, other than this, one more method of measuring anything direct is, for example, if there is a tree, right? Let's say this is basically a tree and you want to measure this height of this tree. Let's say you're standing at a distance, okay? Let's say the height of the tree is h. So let's name this side, this is AB, right? And let's say you're standing at a distance of D from here. Now, if you want to measure this height h, all you need to know is if you just measure the angle, measure the angle theta over here, you can actually get the h. Okay? So we can actually measure the length by comparing it with the standard. Okay, if we are measuring a length by comparing it with the standard, then we basically say that is a direct measurement, right? And in case you are, if you're doing it, right? In that case, like a meter scale, screw gauge, vernier caliper, those that you're using, those comes under direct measurements. This kind of measurement that when you're doing, right? When you want to measure the height of a tree, but how do we measure the height of a tree, right? If the tree is very tall, how do we do that? Then in such cases, we use the indirect measurements. Okay. Now, in case of the direct measurements, the accuracy of the instrument is extremely important. Okay. So now the accuracy of the instrument depends on the least count. Okay, the least count is nothing but least count. So this method of measuring, right? This method that I'm measuring of a tree, that if you want to measure the height of the tree, if you're standing far away, and what is the angle over here measuring. So this is an indirect measurement. Direct measurements are something you can make use of the instrument. Okay, your even traveling microscope, those are again direct measurements. Traveling microscopes also uses direct measurements. but the direct measurements, the accuracy depends on the least count, and accuracy is extremely important, and in that case accuracy depends on the least count, and least count of any device is nothing but the value of the mean scale division by number of the divisions on the vernier scale. In case of a vernier caliper, there are basically, if you see, there would be two scales. One is your main scale, and another one is basically would be a movable scale, which is basically a vernier scale, and those scales will have 10 divisions. So if you're taking a vernier caliper, so here the least count will be the value of one main scale division value of one main scale division by the number of divisions on vernier caliper, on the vernier scale. That gives you the least count of your vernier caliper. Alright, so over here the value of one main scale division, is in this case in vernier caliper, one main scale division will be 1 millimeter. Just one division is just 1 millimeter, and the number of divisions on the vernier calipers are 10. So the least count of the instrument becomes 0.01 centimeters. So up to 0.01 centimeters, up to 2 decimal point values, you can get an accurate reading, which your meter scale will not give. Okay, so a screw gauge will give up to 0.001 centimeter. Alright, so next class we would actually cover the different measurements, right? The indirect measurements, how to measure anything using indirect measurements, right? This measurements, if you want to measure the height of a tree, how do we do it? So here we know the theta value. If you want to know this height, we don't know this height, but we can actually get the distance, and we can actually get the theta, this angle theta you can measure. Okay, so if you do know these things, if you just use trigonometry, in this case I want this side and I want this side, so that gives you tan theta. Theta is known, tan theta will be equal to what? In this case it will be hypotenuse by the distance d. This distance is measurable, this we do not know how to measure, this distance is measurable, and this height length, if you are able to see, that gives you your theta. If theta is very small, then tan of the theta will also be very small. In that case, you can just approximate it to theta is equal to h by d. So from there, if you want to find the height of the tree, it will be d, which is a measurable quantity, into theta. So this value of getting the answer is basically your indirect measurements. Alright, so currently at Unacademy, right, we would be launching a batch for class 11 from the June 8th onwards. So I'll be taking physics, so we'll be meeting every Tuesday, Thursday, Saturday between 5:15 to 6:15, and Jyoti ma'am will be taking math, and Manisha ma'am will take chemistry, and Lakshay sir will take biology. Okay, so alright, so these are the class, so for ISC class 11, the batch is only starting from 8th June onwards. So if you're taking a class, if you're planning to buy a subscription, now would be a great time to buy. And again, we have one more interesting community, right? I'm sorry, one more feature in the Unacademy app, which is basically a community feature. Here, using the community, you will never miss any update from your favorite educators. You can follow any of your favorite educators community. Okay, you can also share feedback directly with educators via pools. Okay, and this is my community link that I've shared over here. Now, one more feature that Unacademy team has come up with is the box bounty. So, in case on any of the educators' videos, if you're actually seeing any inappropriate content in the video, and in case if you're reporting the same, then you can claim a prize. Alright, and again, like and subscribe to the channel. So, click on this bell icon. So, if the next upcoming classes, you would know when they're coming. So, you can subscribe to my channel and also like and share the class videos. Okay, and I hope I can see you in the next class. So again, class 12, right, we have a class happening on the platform in 1 hour, the Unacademy platform. We'll be taking a free special class again in 1 hour. If you like, you can follow there as well. And again, we will be meeting tomorrow. And the timing, subscribe to the channel, because the class timing tomorrow is also is again around 4 o'clock. Okay. Sorry, I don't know Hindi and I'm not very sure what you're trying to tell me. Okay. I'm not. I don't really understand Hindi very well, and I don't know what it is. If you don't mind, you can type at least whatever you can in English, so I can get the picture of what you're trying to say. All right. So we are coming towards the end of the class. If there's no further questions, I'll be ending the session.